I'm going to be talking about a few tips and tricks around Espresso. It's not going to be generically about Espresso, because I think there was a talk about that like a few months back. And also there's been a talk around general testing and different layers of testing, so I'm not going to get into those details. I'm more going to show a few tips and tricks that solves a few problems that myself, my colleagues, or friends have been running into in the past few years. They might not be that groundbreaking. You might have run them across, different blog posts or GitHub repos or what have you, but they might be insightful. They might be interesting. So, just to have a baseline, why are we doing testing? We are doing testing because we want to ensure that the application quality that we're writing is as expected. Our application is doing what we expect it to do, and our users get the experience that they want to, or we intend them to. So Espresso is a way of doing white box, mostly white box UI testing, functional testing. It can be also used for different other things like integration testing, but I'm mostly going to be talking about white box testing. So what is Espresso? Espresso, according to Google, it's a simple API for writing reliable UI tests. So what does reliable UI test mean? Or what does reliable test mean in general? So as you write tests, we want our tests to be consistent, meaning that each time we run our tests, we want to have the same results. We also want the tests to be reproducible, which might mean the same thing as consistent. But what I mean by that is that we want to run our tests in an automated fashion without any manual adjustments as much as possible. And the third thing is stable. So let's say you're going to run your tests, and you run your tests 100 times, and your test is going to pass 100 times. And then for the 101st time, your test is going to fail. Why is it going to fail? Because you're depending on external factors. Whereas your UI test or your test should be tested in isolation. You should be doing hermetic testing, so you can mock out the layers above and below the module or layer that you're testing. So you're going to have these consistent, reproducible, and reliable results. So one of the important parts of this is structure. If you don't have structure, nothing is going to work. Like, and you can use the best tools in the world. You can use Mockito, Espresso, what have you. If you do not structure your code in a way that you can test it, then it's not going to work, or it's going to be a huge pain in the butt to do it. So just a general idea, some code are better to test than other. If you have a code base that is a huge, entangled ball of twine, it's going to be really hard to test it, because you're not going to find things that you want to mock out, that you want to change. You're not going to be able to do hermetic testing. You're not going to be able to do reliable testing, and you're going to fail on your test. And having failing tests is worse than not having tests at all. Like, if you run your test and you think it's green, it gives you confidence. But if it fails, you don't know. It fails because your tests are wrong, you didn't do proper isolation, or actually your application is not working as expected. This doesn't apply to UI testing. So this applies to a lot of things and different layers of testing. This is just a general point. So what to do before you start writing testing? You structure your code. Most probably good idea is to use a tested architectural pattern. MVP is very popular these days, but there's so many out in the world that you can use that allows you to isolate your different layers and do testing of those layers in a hermetic way. We're going to be talking about UI testing this time, so I'm not going to get into like database layer, presentation layer, or model layer. So with that out of the way, let's look at a horrible code. Nobody would write it. I'm not sure it's easily visible. So let's say we have a simple application, does nothing, goes to your popular version control system, fetches a list of projects and displays them. If there's an error, it's going to display an error. That's it, nothing complicated. We don't want to get into the details how we get that from the network. Well, let's say you just started doing Android development. You read about async tasks. So you're going to do this horrible async task in your application on resume. In the background, you do actual networking. If there's an exception, you're going to display an error. If you got the list of projects that you want to display in the UI, you're going to call the UI, you're going to update the UI. So what's wrong here? primarily, async tasks is not necessarily a good idea to use. There's so many things that you can use instead, but that's not the point. The point is that our UI contains logic to fetch and update the UI itself. It contains networking. It might also contain database caching. It's really hard to test the UI on its own. So when we do UI testing, we don't really want to care about the network and the database. We want to know how the UI is going to react to user interaction. So let's say we read about this awesome thing called model view presenter. So we extracted out our provider layer, which will give us a stream of one single list of projects. It could give you a stream of projects as well, not important. We have a presentation layer which has one method, get projects. Don't mind about the details, that we're not using any popular MVP library. This is just for purpose of presentations. So we go to our provider, we get our data. When we have our list of data, we update the UI. If there is an error, we're gonna update the UI and say, hey, display the error. So, and our activity is going to be our view, implementing our view interface, and going to be implementing those two methods. It's not there, and only resume when you get the project. So this pretty much looks the same as the previous one, but there's a big difference. This is much more testable. Not necessarily in this way. I've left a few things out. If you bake these calls into your activity, you're still going to be ending up in the same state as before. There's no way to mock out the layers below. You're not going to be able to provide data for different scenarios. So most probably, you're going to be using some dependency injection framework or some dependency discovery framework, which you can use in your task code to provide mock implementation for your lower layers. How low you want to go, that's your discretion. You might want to mock out your presenter, don't want to care about the providers, or you have your original presenter and then you mock out the providers. Not really important. So let's say you've done all these things, you added Dagger to your application, you have this one component which is called project component, which provides the one project, what was it called? Project list provider. So this is a general setup that people would usually do. So your application holds on to your component. When your application is being created, you construct your object graph, and then you can get the project component from your application and then use that to inject your views, your providers, your presenters, sorry, providers not so much. And then because you want to be able to mock out your dependencies, you provide a way to set your component in your application class. So when you run your tests, you will actually pick up a mock implementation which can inject the mocks so you do the hermetic testing. For this, the Android testing support library provides a few annotations visible for testing. I want to point out that one parameter has been added to 25.x. So now you can actually say how to handle this method if it were not invoked from task code. So you can set protected, private, or none. None will be handled in a way like it was not there. But what's the problem with this? So the first part, organize your code for testing, and then modify your code or force your code to be testable are two different things. So basically, in this case, we expose a method that can be called from your production code, which should not be there. So maybe there's a better way of doing this. Another thing that I would like to point out, you run your application, and this is very simple and doesn't contain any logic, but very often your application onCreate class contains some kind of logic. You initialize libraries, set off some jobs that to be executed sometimes later on. So if you're using this application instance in your test, then all those calls that will be invoked before your test start will actually be using the production dependencies, which might cause side effect if they call back into your code, like you change data, things like that. So how we can do that? Sorry, so this is a small test utility application to set the project component, not really important. So going on. So first, let's declare a interface that is our component provider. Very simple, one method, get the component. And let's say our application, just as before, implements, well, not just before, implements this interface, contains the same methods to get a component, but doesn't contain a way to test component. So how are we going to be able to mock our components, mock our dependencies if we're running our tests? So there's this handy little thing in Android that is called the instrumentation. So in instrumentation is responsible for creating your activities, creating your application. There's all sorts of things. That's one of the basis of how Espresso does their stuff, or Android instrumentation do their thing. So first step, we'll create an application that is our test application. Test application implements the same interface, provides the components, but this one also contains a setter, which allows us to set our dependencies, basically our whole object graph. So far, that's not going to do any good because we might want to create another flavor for testing, but that's not what I'm trying to get at. This application will live inside in our Android task sources. So it's not going to be in our production code. So even if someone wanted to set a component on runtime, it's not going to happen because it doesn't reside in the same source tree. So the way we are going to mock out our application while running our tests is by subclassing the Android JUnit runner. And at the point when our application is being created, before any tests are being run, we basically don't pass in the name of the class that is our production application class. Rather, we pass in the name of our test application. So from this point on, any Android instrumentation tests, unless it's a application test case, but you don't want to use it anyway, is going to be running a test application, which means it doesn't have any logic that will going to be executed before your activity is going to be started. And this allows for more hermetic testing, more isolated testing of your applications. And then just one simple line, you need to use this instead of the Android JUnit runner, but basically that's the only change that you're going to do. I know it's kind of sucky that there's a class.getName when we're supposed to be passing in the name of the class, but it's not going to cause any problem. And also this can be polished to make it more sophisticated to not contain these shortcuts. This is just for the purpose of this presentation. So, and then finally, we update our test utility, which will allow us to set our mock components. So this doesn't really change from what we had before. We just changed a few classes. That's it. So once we got this out of the way and our activities in our tests are going to be able to run in isolation, there's one big problem with Espresso. Or it's not a problem, it's just the way it works. So Espresso works in a way that it performs validations and actions when the UI thread is settling down. So there's nothing running on the UI thread. The problem is when you have animations, they're going to mess with this whole process, and you're going to be ending up in really flaky tests. If you didn't know that, that's very important. It can be disabled manually in the Android developer settings, but either you don't want to do that when you run that on the CI, or when you're running your tasks from the command line or from Android Studio. If you're using something like Firebase, Test Lab to test your application code, not a problem, because those phones have these disabled. But if you're using your own CI or using your own phones, then you might want to do this. There's one way that people usually do this that contains a lot of reflection, which I personally don't like. So I was thinking about another way to do this. So there are these 3 global settings to set the 3 animation scales to 0 so that it will not interfere with our testing. The problem is with this approach and with any other approach is that we're going to be requiring settings, permissions, sorry, to set these settings. The problem is that this setting or this permission will not be granted unless your application is signed with the same private key as your image. So we need a way to set the permission. We can grant this permission through ADB. So just with a single line in our Gradle file, we can actually grant this permission so that our application or our test code in runtime can disable these permissions and then re-enable these permissions after our tests have run. By the way, so this is not going to work if you run your tests from Android Studio by creating a test configuration, but no problem. if you scroll down in Android Studio, I didn't make a picture of this. You can actually add your own custom execution, like external command execution, and you can do the same thing. It's a bit more manual, but still you can do the same thing for your tasks that are running day by day. So a next topic that is, or area that is very popular, being very popular in past years, is RxJava and reactive functional programming. So not what is the problem is RxJava, but what is the inherent result of using RxJava. So let's say you have your presenter, and your presenter has this form method that will get the project. So you usually have something like this. Don't mind that there is no lifecycle management here. But basically, you want to execute your let's say, network requests in a background thread, like on the IO scheduler, and then you want your callbacks to be on the main thread so you can update the UI in a safe fashion. So the problem here is that when you run your tests, damn it, sorry. I'm running out of time, so I'm trying to do this quickly as possible so I can get through. What's that? Okay. Sorry for the technical difficulties. So where were, yeah, cool. So back here. So the problem is that our task application is going to, when we're running our tasks, it's actually going to be executing the same thing in the background thread, even if the provider is being mocked out. The problem is that it's the same or kind of similar as with animations, that it's going to mess with the main thread, or rather not going to mess with the main thread, and Espresso is not going to know about that there is something running in the background. So you make this call, and you're going to be doing something in the background thread, and then you execute your assertions on the UI, but by that time your result didn't come back, the UI has not been updated. So if you're unlucky, then your tests are going to pass. If you're lucky, your tests are going to fail because you know there's something wrong. And what's wrong is that we do not want threading in our tests, or we want to do it in a way that Espresso knows about, that something is running in the background. So there are three main approaches that I've seen over the years. One is through the RxJava and the RxAndroid plugins, which basically sets the schedulers for, sets the three main or four main schedulers. This is very simple. You can package it into a JUnit rule, apply it to your tests, and you will find it dandy. You might not like this approach because it might have side effects, and also some libraries might also set these schedulers, hopefully not. And then it's going to be ending up in an inconsistent state. So can we do something else? Yes, we can. This requires a bit of code change, but as opposed to using those static methods to get your schedulers, you could inject your schedulers. This way, just as with any dependencies, you can provide your mock dependencies, which would be the immediate scheduler, and in your task application, everything would be run in sync manner. Your UI would be updated in a sync manner, and you would not be ending up in flaky tests. What if I don't want any kind of injection? So this is the first kind of thing, is a way to actually wrap your schedulers. I've seen a similar approach, so this might not come as a new thing, but just let's go through it very, very quickly. So in the schedulers, every job is executed in an action. So usually there's a call, something is being executed, that's it. So what we're going to do is we're going to create our own action that when the action is actually being called, when it finishes, we decrement our counting idle resource, which is a idle resource. I don't want to get into it, and I'm really run out of time. So this is one part. We also want to have a way to wrap these actions that are being passed into a scheduler and increment the counter so that it's going to be consistent. And we're going to come back to almost the same thing as we've been doing before. The RxJava hooks allows us a way to pass in a mapper function that will wrap or decorate the actions that are being run on a particular scheduler. So this will allow us to maintain our idle counting resource, which is going to integrate nicely with Espresso. The question still is, why would you want to do this complicated thing, which could be messed with by other plugins or libraries or whatnot? one of the things would be when you want to do live testing, when you're actually not doing isolated UI testing. So another thing, you want to test your fragments. Let's say you have an application that contains that's built up from multiple fragments, and your application is providing a different layout for different orientation, or tablet, or phone, or TV, or whatnot. So you could test all these orientations, but each and every component should run perfectly in isolation on its own. Because a fragment doesn't live outside of an activity, you're not going to be able to drive that Espresso directly. Threat-not, there's a very simple approach, which is basically an Autochaining test rule, which uses an internal fragment activity which can be passed in the fragment name that will be instantiated, and then we can use it just as a activity test rule, fetching the fragment from the activity and then running your assertions and actions on your UI as we usually do. Sorry. Okay. And almost at the end, this is also something not something new, I hope. So let's say you have a login UI, which contains of 2 text input fields, a button, and maybe a other text field that will show an error when you click on the button and the login fails. So you structure the application perfectly, and you're ready to run your write your Espresso tests, and you do something like this. There are multiple problems here. One, there's a lot of repetition. And even though Espresso gives you a nice API, this is really hard to read, especially if you have more measures, more complicated measures. It becomes harder and harder and harder to read. So let's say you have a new employee at your company who wants to understand how your application works, or what are different use cases. What would be the approach for him to understand what the application does? Look at your UI tests. You know what's going to go on. But if you look at this one, or even more complicated things, it's going to be really, really hard to understand what's going on. So a pattern to apply is called a screen robot, which is nothing new. There's no library that you need to use. You can roll your own, or you can use a third-party library if you want. But basically, your screen robot is a way to abstract away the certain interactions or flows or scenarios or just helper methods to actually implement your different scenarios. So for our case, we had the repetition of inputting the username and password, and then pressing the login button, and then we had a duplicate code for actually testing what's going to be displayed in the text view when login fails or when the login is successful. So basically, we create our methods, which says login, which will do the same thing as before. We have our check login error and check login not shown. And then we rewrite our test, and we get this. Not is it only shorter, it reduces code duplication, but if someone wants to understand what's actually happening, looking at this, you will understand what the actual user flow would be for the different scenarios. So it helps you organize your tests. It makes it easier to understand, easier to read, and easier to extend. Just think about if you change the way your UI looks, your IDs change, your structure change, you use a third-party library, your screen robot is going to look exactly the same. Username, password, and interaction to actually log in. So your test will not change. It's just the implementation, how those interactions are being carried out. And then just a few more things at the end, trying to go through quickly. So I hope everybody remembers there are just 3 animation settings that you need to disable to actually have your stable settings. So this is something that one of my colleagues came across not long ago, is that even though those are disabled, item animators on recycle views are going to result in flaky testing in the way they're being implemented, especially the default item animator. So another trick that you might want to apply is to reset your item animator to not get those flaky results. And the last thing that I wanted to talk about is recycle view scrolling. So if you have spent some time looking around Espresso and how things are being implemented, this is also something one of my colleagues did, but I think it's very useful to explain. The way you perform a scroll action, or Espresso performs a scroll action in recycle view, is the following. It's going to simulate the same interaction as a user would do, but not from the UI. if you want to find a certain item, it's going to go through your adapter, create each and every view by calling onCreateView on your adapter, and it's going to bind it and then match against it. So basically, this is going to go through all the data, which is very, very wasteful. It's not simulating the user interactions as closely as we would want to. Plus, because those items are not going to actually be attached, certain assertions are not going to work. So this is yes. So no. That's it. Sorry. So the original implementation, as you see, it goes through, creates the views, binds the views, and then does the matching. And the updated one is going to do almost the same thing, but for each and every adapter position, we actually will call the recycle view to scroll to that position. So those items are going to be created by the recycle view, hence simulating the natural way of things, the natural way things are happening. So you're going to be closer to what we expect, and our matches are going to work more perfectly. So, yes. Last topic that I want to touch on is permissions. So with newer versions of Android, we have the runtime model, which is a bit closer to iOS. So as you write your tests, certain actions might require permissions. And you might argue, oh yeah, I need a way to actually grant those permissions. So I would argue that no, you don't have to, because one, you should mark those calls out, or two, you should mark those calls out. But if you really want to do that, Espresso on its own will not provide you the tooling for that. The reason is that Espresso only is going to work in your application process, but cannot invoke actions outside of your application. Will not be able to click on a dialog that is being presented when a permission is requested. So for this case, you might want to use something as can someone help out? My brain just, thank you. To actually perform actions on controls outside of your application. So the problem is, I think you really shouldn't be doing this, so you should be mocking these flows out, because you don't want to test what the framework does in case if you don't have permission. You cannot simulate cases when you actually have the permission, because it's going to change for each test run. So subsequent test runs will not be consistent, they're not going to be repeatable. Plus, it relies on how that dialog actually looks. So if that changes, or you run your tests on a device that is being customized by a manufacturer who I don't want to name, then your test might gonna fail and it's gonna be flaky. So I think that was my last slide. Sorry for kind of speeding up at the end, and thanks for listening.